Any nuclide that is unstable will definitely undergo what we call what? Decay or disintegration. But a stable nuclide will hardly undergo decay. Now, they ask you now, what is a stable nuclide and what is what? An unstable nuclide. Someone asks you now differentiate between stable and unstable nuclide. Is there anyone that can, I think I said something like that, did I? Okay, let me help you out. When a nuclide is stable, it means that, for instance, if I have sodium, maybe sodium 2311. Look at this now. If I have sodium 2311, what's the mass number of this sodium nuclide? 23. And the atomic number is what? 11. So the mass number is A. I can say that A equals to 23. Then the atomic number is what? Z, which is what? 11. To find the neutron number, because there are two particles in the nucleus. To find the neutron number N will always be given as what? The mass number A minus what? Atomic number Z. Now, to find my N will now be what is A? 23 minus what? 11. What do I have for N? 12. What was the number of proton? 11. What's the number of neutron? 12. That nuclide is what? Unstable. If a nucleus have the same number of neutrons and the same number of proton, that nucleus is what? Stable. But when one of the particles is in excess, then that nucleus is what? Unstable. And any unstable nucleus can undergo what? Decay or radioactivity. But in some other cases, a stable nucleus can also undergo decay if and only if the nucleus is in what? An excited state. That is excited. If it's normally in a ground state and it is stable, it will not undergo any disintegration, any decay. So in our mass defect, we are going to look at, if you have this nuclide now, every nuclide will have an actual mass. The actual mass is also called the mass of the nucleus, which is nucleon. What did I talk about nucleon? I said that nucleon is what? What is nucleon? Did I mention nucleon? Yes. What did I say is nucleon? Nucleon is the combination of what? Proton and what? Neutron. Don't forget we are playing with what? The nucleus of an atom. And in the nucleus, there are only two particles we are to talk about. And those particles are what? Proton and neutron. Electron is completely out of this particular equation. It's out. Electron always revolves around the atom. But in the nucleus, we have a proton and neutron. So everything we are going to be talking about in this nuclear equation or nuclear physics is just between what? Proton and neutron. We will hardly talk about electron, except in some few cases. So when you combine nucleon, it's simply what? Nucleon means proton. Proton plus what? Neutron is called nucleon. Another name for nucleon is mass number. Nucleon number or what? Mass number. Now, I will now tell you that when the number of neutron is the same as the number of proton in an atom or in a nuclide, then that is what? Stable. But when one is in excess, unstable. Now, mass defect, subtopic, please put it down. Mass defect, let's now talk about this now. Mass defect. Mass defect. Mass defect. So before we define it, so just put this down. The mass of the nucleus, is less than, the mass of the nucleus is less than the mass of the neutron and that of the proton. Are we there? The mass of the nucleus is less than the mass of what? The neutron, and that of what? Of the proton in the nucleus of an atom. The mass of the nucleus is what? Less than the mass of the proton, and that of what? Of the neutron in the nucleus of an atom. Full stop. This difference in mass between the nucleus, between what? The nucleus and its constituent particles. This difference in mass between what? The nucleus and its what? Constituent particles is called mass defect. The difference in what? In mass between the nucleus and what? And its constituent particles is called what? Mass defect. What are the constituent particles of the nucleus? Proton and neutron. That should not be the case this time. Alright? So anytime they say define mass defect, you can just say that mass defect is the difference in mass between what? The nucleus and what? And the combination of what? Proton and neutron. It is given mathematically as, mass defect is given mathematically as change in M equals Z mass of proton plus N mass of neutron, then minus the mass of the nucleus. Please take note of that. Change in M is what? ZMP plus NMN minus NUC. Where, by now you should know, where Z equals to what? The atomic number. Atomic number of the nuclei. N equals what? The neutron number of the nuclei. How do we always obtain our N? We obtain our N by subtracting what? Our Z from A. Remember, I said we have a nuclei Y, and this is A, and this is what? Z. A is mass number, Z is atomic number. To find the neutron number, it means that N is always given as what? A minus Z. You should take note of that. So that's how you get your N. Then what is what? The NUC is given as what? Actual mass. Actual mass of the nucleus. Actual mass of the nucleus. So Z, atomic number of the nuclei, N, neutron number of the nuclei, and how to obtain N is subtracting Z from A, and then this is the actual mass of the nucleus. Every nucleus will have the actual mass from the beginning. If we now find the other constituent masses. Are we there? All these are constants. Quickly, let me give you the values. They are constant. For instance, as an MP. MP is constant. Mn is what? Constant. So let's see. The mass of proton in atomic mass unit will be given as mass of proton equal 1.00728 U. That's mass of proton. Now mass of neutron is 1.00826 U. Okay, so X67 rather, X67 not X62, X67, those are constant that will be given to you. So X67, X67U. Now, 1U. One U is 1.6607 times 10 raised to the power minus 27 kilogram. That's what I call U. U, let me show you today. What U is the same thing as ANU, which means what? Which means atomic mass unit. So anytime you have 1.0017728 U, and they ask you to convert this to what? To kilogram. To convert the mass of proton to kilogram, what would that be? Mass of proton will now be Mp will now be 1.00728 times in place of U. U is now what? 1.6607 times 10 raised to the power minus 27 kg. If you multiply this, what will you have, please? Put that down your calculator quickly. Multiply 1.00728 times 1.66. 1.6729 times 10 raised to the power minus 27 kilogram. That is mass of proton in kg. Whereas in atomic mass unit, you have this. You have to note that. And all of you are going to, I hope you all have calculator, because you're not always comfortable where you don't do copy. I want you to punch. You're going to be punching a lot in this class today. So ensure that you have a calculator. You will not use your phone as calculator. Alright, so quickly, let's also let you know some other important constants, like C. This C, the speed of light is always what? 3.0 times 10 raised to the power 8 meters per second. That's one of the constants you should note. Another constant you should note is electron volt. What is 1 electron volt? (1.6 times 10 to the power minus 19 joules. I mean, 1 electron volt in this is 1.6 times 10 to the power minus 19 joules. Then 1 mega electron volt will be given as, who knows? That should be 1.6 times 10 to the power minus 13 joules. These are the things we need. Well, if 1 electron volt is 1.6 exponential minus 19, then 1 mega, what is mega? Mega means, where's my duster? Okay. This duster is not very okay. Now, 1 mega is the same thing as what? 10 raised to the power 6. I mean, most of you buy data, megabyte. You buy gig. 1 gig, gigabyte. 1 gig is equivalent to what? 10 raised to the power 9. 1 terabyte, terabyte is equivalent to what? 10 raised to the power 12. At least at this point, you know this thing. If you see 10 raised to the power 6, it means mega. Gig, that's giga, and tera. So how do we now have 1 mega electron volt be raised to power minus 13 is simply because if 1 electron volt equals 1.6 times 10 raised to power minus 19, then 1 mega electron volt will now be what? 1, okay, write it like this, 1, then what is mega? Times what? 10 raised to power what? 6. This mega is 10 raised to power 6. Then times electron volt. Electron volt is what? 1.6 times 10 raised to power minus 19. So all you don't need to have is going to be 1 times 1.6 remain 1.6. Then times 10 raised to power 6 minus 19. What is 6 minus 19? Minus 13. That's how we arrive at this 1 mega electron volt with 1.6 exponential minus 13. You will know the effect or why this being spelled out now. You will know it as we progress. So take note of this constant. And let's take one example first. I will solve 2 examples. I will give you one to solve. And I expect all of you to be able to solve. So you look up very carefully. Example 1. Find the mass defect of copper 6923. Copper 6929, rather. Look at this. Find the mass defect of copper 6929 if the actual mass of copper 69 is 62.9136 U. The actual mass of copper, hold on, it's not copper 63, not 69. Sorry about that. Copper 63, but it cannot be 69 here, come and have 62. So copper 6329, the actual mass of the copper is this. So you have to find the mass defect. In every question, the actual mass will be given. So look up carefully now. All right, I will solve this one for you, and I expect you to solve some other ones I will give to you. So you have to find the mass defect of this copper 63, given the actual mass as this. What do? Recall the equation for mass defect. What's the equation for mass defect? Change in N equals to what? ZNP plus N1 Nn minus 1 mass of the nucleus. In this nuclide now, what is our Z in this nuclide? What is Z? Our Z is what? 29 or 69? 29 is our Z. That's this. So our Z is 29. Now what's going to be our N? What's going to be our N? The neutron number. Our N will be 63 minus 29. So our N will be, what is 63 minus 29? 34. Is this nuclide stable or unstable? This nuclide is certainly unstable because you can see 29 is to 34. It's not stable. So any unstable nuclide will always definitely undergo what? Decay. First we talk about half-life. You see the time it will take for it to decay to have another stuff. Now you have this. These ones are already known. That constant will be given to you when you want to solve. They will be given to you. So now let's apply this. Our change in M is when you want to solve this, you don't approximate the way it is. How many decimal places after the one? That's 1, 2, 3, 4, 5. I mean, leave them in your 5 decimal places. Even though the actual mass is 4 decimal, then the mass of the neutron and the mass of the proton are in 5 decimal places, allow your answer to remain in 5 decimal places to get to the end. So let's see. Change in M will be Z. What is our Z? 29 times. What is mass of proton? Mass of proton is 1.00728. Then plus, what is N? 34 times. What is mass of neutron? Mass of neutron is 1.00867 minus. What is mass of the nucleus? 62.9136 U. So play with this. Multiply 29 times this. What do you have? 29.21112. Is that okay? 1, 2, 3, 4, 5. All right. Then plus. Multiply this. 34.29478. Then minus 62.9136 U. Take note, all these are U. I'll put them at the end. So add these two together, what will we have?
63.5059.
63.5059. Okay, maybe 0 there. 5059 minus what? 62.9136 U. Take note, this is also there's U there. So subtract, what are we going to have?
0.5923.
0.5923 U. That is your mass effect. That is your mass effect. 0.59. That was a very small difference, a very small value. They're very powerful. Yes, ask.
So since we are giving the value of it, can't we use it?
What?
Since we are giving the value of it, can't we use it?
At the end, don't worry. Let's get to the U first. Now, if I ask you, because mass effect always goes with what? Binding energy. When you solve your answer and leave it at U, if you want to go further to find the binding energy, then you have to interpret the meaning of U, which is already there. So it means that if I want to leave my answer in kg, because if I say proceed to finding the binding energy, which I'm going to ask you now, then you have to convert this from atomic mass unit to what? To kilogram. So assuming I want to write it in kilogram, so I can say therefore my change in M will be given as 0.5923 times what is U? 1 U is what? 1.6607 times 10 to the power what? Minus 27 in kilogram. So what's the final answer in kilogram? What's the final answer in kilogram? Just multiply that. See what it multiply this, what do you have?
9.876 times 10 to the power minus 28.
Okay. 9 point, you say what? I want to confirm the answer. I have a
9.8363.
9.86.
No,
83.
8363.
261.
Okay, let's leave it at 5 decimal. 83631. 2 times 10 raised to the power minus 28 kg. That is your mass effect in kilogram. This is your mass effect in atomic mass unit. Any unbeliever?
All saints.
Any unbeliever?
All saints.